Uh, we are going to be discussing something on normal distribution today. And we are going to learn how to make use of what we call the empirical rules. Let's move on to the topic. What are normal distribution? Sometimes you are going to realize that when you observe some of data sets very well, you realize that they form a normal distribution curve. How do you get to that? One thing you are going to discover, which is very important, is that a normal distribution curve, a normal distribution data, we have all its data sets happen to have a certain value, and that is mean, median, mode to be the same. When you calculate the mean, you realize that it's the same thing as the value you get when you calculate the median or you calculate the mode. So notice that all the three central tendencies that we use to calculate in statistics, mean, median, mode, happen to equal or approximately equal. So when you have all the three values happen to be exactly the same thing, we say the data is normally distributed. And when you have the value very close to each other, for example, mean is 7, and you have the median to be 6.9, and you have the mode to be 6.95. You can see all these three values are very close to each other. In that case, you can say they are approximately normally distributed. So some special thing about normal distribution data are these. Number one is that they are symmetric. Don't worry, later when we get to measure of shape, we learn what we mean by symmetric. Or actually what we mean by symmetric is that you can in fact divide them into equal parts. When you divide the shape into equal parts, you will realize that the right-hand side is exactly equivalent to the left-hand side. And that is actually the reason why we say they are symmetric. Number two is that single peaked. In fact, when you draw the graph of data that are normally distributed, you will realize that there is only just one peak. This is what we call peak. Where the curve goes up is what we call the peak, and that only exists once. So you can see that this data is going like this, the curve is going like this, it goes up here, comes down, and it never goes up again. So that's what I mean by the peak. Another thing that they have bell shape, all normal distribution data, we have a bell shape. In fact, as you can see here, you can see this shape drawing look a little like a bell. All right, that is talked about the two properties about normal distribution data. Now let's see how to make use of them. You can easily describe all normal distribution data using the mean and standard deviation. In fact, that is the two important things we need, and how the data is being distributed can easily know. You can see this is how normal curve always look like. There are something you should observe well here. You realize that this middle point is where you have the highest point, and the same place happen to be the mean. So if you have a graph like this representing all your data sets, this place will be your mean, it will be your median, and in fact, the mode. When you deviate by one standard deviation, we say you have minus one standard deviation and plus one standard deviation. That means you add one standard deviation to the mean, and you subtract one standard deviation to the mean, from the mean, rather. So what is what we call empirical rule? What does empirical rule state? Empirical rule tells us that if a data is normally distributed, we are going to realize that 68% of data lies between one standard deviation. What are we saying here is that if we have the mean to be something, and we've gotten the standard deviation, if you add standard deviation to the mean and you have subtract standard deviation from the mean, these two values that you've gotten, you can use them to form a range, and you can always 100% sure that about 68% or approximately 68% of data will lie between that range. And if you have two standard deviation being used, you subtract two standard deviation and you add standard deviation to the mean, then that gives another range. About 95% of the data is going to be noted to lie between this range. And when you are doing with 3 standard deviation, you are going to discover that 99% of the data lies between this range. Actually, this might not make sense enough. Let's try to show what we are trying to do. For example, let's say you have a graph that is a data set that is normally distributed. At the end of the day, you calculate the mean of that data set, you realize it's 80. Then you also calculate the standard deviation and you realize this is 5. Now, what we are saying, or what empirical rule is trying to tell you, is that if you can deviate from this mean by one standard deviation, what we are saying is this. This is the mean. This is standard deviation. If you keep one standard deviation, remove it from this mean, you are going to have 80 minus 5. And that gives what we call 75. Now, if you had one standard deviation to it, you are going to have 80 plus 5. That gives you 85. In that case, what empirical rule is telling you is that from 75 to 85, if you look through all your data sets, you are going to realize that about 68% of your data fall between 75 and 85. And that is what is being represented in form of graph here. You can see one standard deviation plus one standard deviation, that's 85, 75. What we are saying is that between this and this, there will be 65% of data between them that lies between the range. That's not all. In fact, if you are dealing with two standard deviation, that means instead of subtracting 5, you now pick two standard deviation. Standard deviation here is 10. As you can see, one standard deviation is 5, 2 will be 10. So if you subtract 10 from this 80, you are going to get 70. If you add 10 to 80, you are going to get 90. So what we are saying is that 95% of your data will lie between 70 and 90. Okay, let's move into real practical and see how we can apply this thing we are trying to say in solving many questions. But before I move into that, let me explain this graph clearly. What we are talking here, if you have the mean, from the mean to one standard deviation, I mean, when you had one standard deviation to your mean, what happened to be between them is 34% of them will be between them. And 34% will be between the mean and minus one standard deviation from the mean. And that is why altogether from year to year, we give you 68%, which we have said earlier. What is stated by empirical rule. And if you realize from these two second standard deviation and standard deviation here, there will be 95%. In fact, if you subtract 68 from 95%, you are going to realize that you have 27 left. And that 27 is being divided into 2. So 13.5 will be here, 13.5 will be here. In fact, you can note this graph where this is the graph that can answer many questions they can, no matter how they twisted the graph. If you can just master this graph and notice each value between them, then that is okay for you to answer any question. And how it's got to is not hard at all. Like I said earlier, 68 is what is here, and the 68 is divided into 2. We take it in 2 parts. Then when you say 95, and that is from this part to this part, we already know this place and this place is 68. If you subtract 68 from 95, you are going to end up with 27. So divide that 27 into 2 so that half part will be here, half part will be here. You have 13.5, 13.5. So 13.5% will be between 1 here and 2 here. So it depends on the value. Let's take a look at the sample so that we can understand what we are trying to say here. Let's say example 1. Look at this question. The question states the distribution of the height of adult American male is approximately normal. Okay, that means it is normally distributed with the mean of 69 inches and the standard deviation of 2.5. That's all we need for any normal distribution data. Now we've gotten our mean and standard deviation given. Then what is the question? The question says, between what height do the 95% of men fall? The person is asking us that, what range do you think 95% of men will fall? This is quite easy. We just try to apply empirical formula or empirical rule rather. Let's see how we apply this. We know our mean is 69. Our standard deviation is 22.5. But if you remember the rule of empirical, empirical rule states that 68% of data will lie between one standard deviation, while 95% will lie between 2 standard deviation. That means if the person is asking for 95% of men, it is very easy to realize that this thing is going to be between 2 standard deviation. That means all we need is to deviate by 2 standard deviation from the mean. And let's see how I'm going to do that. So all I'm just going to do is to calculate the mean minus 2 standard deviation and mean plus 2 standard deviation. That will give me the range of those men that are going to lie that happen to be 95. That is the range that 95% of the men is going to lie. Let's see how I do that. So I will say mean minus standard deviation will give me 2. This is error, sorry. This is supposed to be 2.5. If you can check the question back, the standard deviation is 2.5. So I will have 69 minus 2 times 2.5, and that will give me 69 minus 5, which is 64 inches. So I should apply for plus 2 standard deviation here too. I'm going to have mean plus 2 standard deviation, 69 plus 2 times 2.5. Remember, I'm using 2 standard deviation here. So that gives me what? 69.5. 69 plus 5. So 69 plus 5 here is going to give me 74. So that means 95% of my data are going to lie between 64 inches and 74 inches. And question is easily done. So you can just conclude that 95% of men will fall between the range of 64 and 74. And that is very easily done. Shall we proceed to example 2? Let's see. Another question is this. The question asks again that, what percentage of men are taller than 74 inches? This is a little tricky question. The question is asking, what percentage of men are taller than 74? In fact, let me show you what is happening here. For 2 standard deviation here that we have written, we've gotten 64 and 74. Let me show you how it will look under the graph. If I were to use my graph to plot it, I will have my 64 here and I will have my 74 here. So the whole graph we have between everything here from year to year will be what? 95%. That's what we are trying to say. So 74 will be here. Those ones that are going to be above 74 are going to be the remaining percentage we have here, because this is the boundary for 2 standard deviation and minus 2 standard deviation. So anyone that will be above or taller than that will be above these 2 standard deviation. And you can see how many percentage do we have left here? We have just 2.35 and 0.15, which is summed together to 2.5%. So in fact, 2.5% of them are going to be what the question is asking. But another way we can easily solve that is this. Let's see, if I don't want to use graph, the question is asking me that what percentage of men are taller than 74 inches? In fact, the question is asking that how many of them, percentage of them, above 74 inches? That's the question exactly. Now let's see. Since 95% of men fall between 64 and 74, we already calculated that one in example 1, and we are able to confirm that 64 inches and 74 inches is what 95% of them will fall. Now, how many percentage left? That is the question. There are just 5% left out of 100%. 95 is between this and this. That means 5% are going to be outside this range. 95% are between the range 64 and 74. That means the remaining 5% are going to be outside this range. If remaining 5% are between outside this range, this is telling us that 2.5% will be above the range, while 2.5% will be below the range. That's how to make the interpretation. There are 5% outside the range. That means we are going to divide that 5% to 2 and get 2.5. So below the range, we should have 2.5%. Above the range, we should have 2.5% also. And the question is asking those ones that are above 74. And in that case, you can easily say that since above the range, there are 2.5%, that means there will be 2.5% above 74 inches. In fact, if the question also asks us that, what percentage of men that are going to lie below 64 inches? The answer will still be 2.5%, because we know below the range, there are 2.5% also. I believe you understand that. That's how to implement or how to apply empirical rules to solve some question. Okay, let's see another example. Another example is here. We have the shelf life of a particular dairy product is normally distributed with a mean of 12 days and a standard deviation of 3 days. Now the question is about what percentage of products last between 12 and 13 days. Let's see how to deal with this. 12 and 15 days. But just notice the word 15 days here. This 15 days here has something to do with, well, you should ask yourself, if the mean is 12 and the standard deviation is 3, how many standard deviations should you subtract or add to this 12 to get 15? In fact, you realize that there is just only one standard deviation that is needed. So if you can add one standard deviation to this 12, you are going to get what? 15. That means we need to form our range using one standard deviation here. And how am I going to do that? Let's see. I have the mean to be 3. Sorry, standard deviation to be 3, or standard deviation to be 3. The mean is 12. And the range that we are actually trying to solve is 12 to 15. So now mean plus 1 standard deviation here is going to be 12 plus 3, which is 15. Mean minus 1 standard deviation will give us 12 minus 3, which is 9. Did you get that? Now, according to empirical rules, when you deviate by 1 standard deviation, 68% should lie between them. In that case, we can discover that, or we can infer that 68% of the products last between 9 and 15 days. Remember, we deviate using 1 standard deviation, and we add and subtract, and that's how we get our 9 and 15. But the question is not asking for between 9 and 15 days. This question is asking for between 12 and 15 days. So how are we going to deal with that? This is a very easy thing. Remember that the mean is 12. Now, if the mean is 12, in fact, we can actually divide this 68 into 2. If we divide this 68 into 2, we can say that 34% will be between 9 and 12. Since 9 to 15, there are 68. You can see the middle of 9 and 15 is 12. So that means between 9 and 12, there will be half of this. And between 12 and 15, there will be half of this. So that means 34% will be between 9 and 12. And the remaining 34% will be between 12 and 15. And in that case, the question is actually asking for 12 and 15. And that is what we are able to solve right now. So we can say 34% of the products last between 12 and 15 days. I think you understand how this works. So we just solved the question. Question is easily done. Okay, that is that about that. Let me try to show you another example, which is a little test. Another example is here. Look at this question. The question is asking, we have the score of an IQ test have a bell-shaped between this. Okay, as a bell-shaped distribution. Remember, one of the properties of normal distribution is bell-shaped. So when they tell you that something has a bell-shaped distribution, they are indirectly telling you that the same data set is normally distributed. So here we have the mean to be 100 and standard deviation to be 10. Now, the score, the empirical rule implies concerning individual with IQ score of 10, 110, 120, 130. What can we say about them? Now, for IQ of the one with 10, 110, you can see, without even telling you, you would have known that they deviate by 1 standard deviation. Because in fact, if you add 10 to the mean here, you are going to get 110. So that means the mean here, they are deviating by 1 standard deviation. And what can we denote? You can denote that approximately, if you subtract 10 from here, and you add 10 to this, you will have 90 and 110. So that means between 90 and 110, there will be 68% of them. So you can say approximately 68% of the IQ score in the population lies between 90 and 110. That's the interpretation. For 120, you realize that they have deviated by 2 standard deviation. Because in fact, 2 times 10 will give you 20. And if you add it by 100, you are going to have 120. So if you subtract the same 20 from 100, you will have 80. That means 80 and 120 is what we have as our range for 2 standard deviation. And we can apply empirical rule and say 95% of our data relies, or 25% of the IQ score relies between 80 and 120. That's okay. And if you deviate by 3 standard deviation, you can still apply the same thing. You will have 130 and you will have, if you subtract 30 from 100, you have 70. So that means about 99.7% relies between 70 and 130. And that is what we can denote. And then let's understand more explanation on this IQ question. And what more explanation can we denote? We can denote that if 68% of them lies within 90 and 110, then it must be that 32 of them lies outside the interval. Like I used the other example, 68% are between 90 and 110. That means the remaining is 32%. That means 32% will be outside the range that is being given. In that case, if you divide that 32 into 2, you are going to have 16%, 16%. That means 16% of people are going to be above 110 or above the range. Why y 16 will be below. So we can simply imply that above 410, then there will be 84% below it. So we can interpret the two intervals in that similar manner. I hope you understand this thing and enjoy this video. Consider to subscribe. You can also comment below if you have any question to ask me. You are blessed.